Definitely excited about the intersection of AI and blockchains and how trust can be built within AI.
You mastered at CMU, you worked on building Verifiable Cloud and stuff on these lines.
A given prompt run 5 times will probably produce different outputs each time. So I think the non-determinism part is probably where there's more excitement and creativity around that.
Welcome to Ground Zero, Vishnu. What are you most excited about these days?
Thank you, Himanshu, for having me here. Definitely excited about the intersection of AI and the blockchains and how trust can be built within AI. So I would say that's the thing I'm most interested in nowadays.
How do you find trust? Trust in AI.
Yeah, trust in AI is like there's a few different types, right? One is the functionality of it. Does it semantically do what it's supposed to do? There are things like hallucinations, the correctness of the AI. So that's just one part of it. The other part is when it is executed by certain actors, is it being executed in the way that the actors said they would? So the second part becomes quite important from an agentic AI standpoint. So that's I think I would say the definition of trust.
For our guest, let me introduce Vishnu. So Vishnu is a CTO at EigenLabs. He is leading engineering over EigenCloud, which is a verifiable cloud designed for agentic era. And most interestingly, he previously served as CTO at Kraken and StockX, where he was building secure and scalable infrastructure within high stakes environment. And he also worked at Amazon and authored Eigen's deterministic work. I mean, I guess this is one of the work being aligned with what thinking machines and Grok is doing. I'm just curious what how you define what your career trajectory has been like, and the experiences over there.
Yeah, great question. So I would say, I've actually even before that, I worked in Silicon. So actually, it's truly full stack in the sense that working on the what's called the CISC architecture at Intel x86 architecture. So that's where I started my career in industry, and then moved up the stack, if you will, into operating systems. This is at Microsoft. So it was a lot of fun working on software that tons of people use in the world, and then moved again up the stack into cloud. So at Amazon, I was part of the team that ran Dynamo, which is the world's first NoSQL industrial scale storage system, and that actually had foundations in things like Merkle trees and the Gossip protocol. In actually what Satoshi wrote a year after we published the paper. So it's pretty exciting. That's actually how I got into blockchains a little bit. And then throughout my life, I've been, all the way from neural nets in the late 90s. So to see the evolution of CNNs and RNNs and, how it's come about at the scale that we are. It's pretty exciting to see all those developments. Been through a couple of AI winters and summers. And I think we're in the summer for a bit here, so it's pretty exciting. And then and I would say then I worked in centralized exchanges. We're talking here about nanosecond latency that we're looking at that can affect financial transactions. So obviously building data centers. Again, there's a lot of commonality between blockchains and crypto, and a lot of the mining companies have now become GPU farms.
Mm-hmm.
So it's a lot of like great intersection there.
Yeah.
The techniques. I'm very much a first principles thinker. So when I think about the electrons flowing in the transistors, and then thinking about superscalar execution or NVIDIA's architecture, let's say, of GPUs, all the way from warps, to thread scheduling, Tomasulo's algorithm. These are all things that have been around, but it's about composing all these to achieve some good outcomes. That's the thing I'm most excited about. So in some sense, science has not changed, but the application of it has gotten more interesting.
You talked about you worked at Intel with that CISC architecture, and this is one of many times I have encountered people who have similar trajectory, who have worked at Intel in low level programming stuff and now working on AI stuff, post training, doing RL, and a lot on the frontier. So, is there some cross connection? Is there some black box? How do you link up with the two systems, the AI and then the low level thing? So, what's your mental model here, how you connect the dots with what you have learned. So you studied, you did your master at CMU, you worked on this stuff. Then how you're working as a CTO in AI, or working on the frontier, or building verifiable cloud and stuff on these lines. So how do you connect the dots, and how one can go if they're working on low level stuff, at least let's say in systems core, CS core, and then bringing up to the frontier of AI. So how's your journey been like? How you were able to to connect the dots, and yeah, going on that scale?
Yeah, that's a great question. Again, as I said, I was like, very much a first principles thinker.
Yeah.
So all the way from what happens in tunneling, how does the TSMC fab system work, or how does ASML actually, how are they a monopoly in the industry with the manufacturing process in the Netherlands? So I'm very curious about all of these things. I think the first thing I would say is the curiosity for me is the most exciting thing. And then I go to let's say again, a computer science first principles. So just like how there was assembly language, like I actually programmed on, the x86, architecture using assembly language on microprocessor, right?
Amazing.
So it was quite, quite a thing. And then compilers came around. Of course, compilers were already there when I started. And so what that is another abstraction on top of assembly language, so that people can, engineers can stop worrying about memory management directly and things like it. So, and then, fast forward a little bit, one of the ways to think about Gen AI, it's another higher level compiler on top of, existing compilers. So this is the probabilistic aspect of like, you give natural language inputs, in other words, prompts, and you expect some magic to happen on the other side. But at the end of the day, it's like compilation that's happening. At this point, you have in the multi-parameter models, or the trillions of parameters and the weights, you have electrons and bits flowing and weights being computed, and matrix multiplication eventually, representing the embeddings. And then out of that, you spit out like a token, the next token. For me, that's a little bit like a compiler itself, but at a much higher level of abstraction. So that's how I try to think about it. These are all compositional. Of course, the element of non-determinism is quite new, because specific to like this abstraction model, because you can have compilers that can be like emitting like different types of bits on different runs. But I would say it is almost the norm within Gen AI, where a given prompt run 5 times will probably produce different outputs each time. So I think the non-determinism part is probably where there's more excitement and creativity around that. So yeah, but at a first principle standpoint, I think it's ultimately just electrons flowing in different ways, and how humans decide to orchestrate these to get, the jobs to be done. So
I really like how you related your systems view with how you see bits and electrons flowing, and how and the token processing of it. You talked about this agentic stuff, like how Eigen is working on it. But anyways, I'm just curious about what are your thoughts on OpenClaw?
Yeah, well, first off, I think the creator of it, if you look at his GitHub, he had like 200 different projects.
Of course,
before.
I mean, in last couple of months, what I got is like he was building blocks of OpenClaw for quite some time. I mean, people say like OpenClaw is like a night achievement, but it was not. He was just building for like months, for like 3-4 months already. Yeah.
And that's, for me, that's the more interesting thing about this is like, I mean, I'm sure people have thought about, that kind of thing, a personal assistant, autonomous agent, and all of that. For me, the interesting thing is the timing, right? Which particular, deployment on GitHub actually goes viral. It's hard to predict that.
Yeah.
And so, I think that's one, view I have of that is like, sometimes it just takes the perfect time, the perfect everything for things to go viral and everyone to notice it. Now coming to like, in terms of like, obviously, in say like isolated environments, where you have a Mac Mini, for example, and you're running these things, create brand new, fresh accounts.
Exactly.
Really fun to play around with and get stuff done. It can execute over time, with some level of context and memory and all that locally, can definitely make you more efficient. I've seen it myself, with calendaring and things like that. On the flip side, I would say, things like security, reliability, and all of these things, definitely need to pay attention. You've seen like some early vulnerabilities that have been reported. So of course it's used with your own at your own risk kind of thing. But I think eventually once those are solved, even the agentic security models are evolving as we speak. So I think there's going to be a lot more innovation over there. Just the regular OAuth, OIDC framework, or your SAML and IAM framework, or even roles-based authorization is not going to be enough, because agents, are also doing tasks, and you can predict ahead of time, like you could do in static analysis with code, what that agent will end up calling when the LLM part of it is exercised. You can't tell which tool is going to invoke. So how do you set security for something which is dynamically evolving?
Yeah, sure.
And so, which is why I think new paradigms like task-based authentication, what I think about as attenuation scopes, so the principle of least privilege, how do you apply that when one agent delegates its work to some sub-agent? That sub-agent has to have lesser privileges. So how does this whole thing work? How do you audit this? How is the determinism part of it? I think these are all just to expand that, I think what OpenClaw or any future generation of it can be, or types of agents. I think there's a lot more to be done for people to be feel secure with, especially high stakes when you have a wallet or your password. I would be, of course, definitely very thoughtful before deploying, something like OpenClaw.
For the people who don't know what OpenClaw is, you might be living under the rock. It is like Reddit for AI agents, where you can just pull off your agents to do transactions, to run your Telegram, WhatsApp. To personify yourself and get things done. And I guess there are multiple versions of it right now. People are just building on top of OpenClaw, on the vertical, on that aspect of it. I'm curious, what are some of the most interesting projects, experiments, hacks you have seen over OpenClaw that made you feel like wow?
Yeah. If I was to talk about the hacks, there was some quote unquote 0-day, exploits. There was some level of prompt injection where you could exfil sensitive data. So that was one. And just, outside of board book and all of that, it's kind of almost dystopian to see agents having Facebook. What does that even mean? It's kind of who's going to consume that? Ultimately, I also think about with AI.
Exactly.
If agents are doing a lot of these things and productivity is great, so that's a great use case. But if they consume, producing a lot more, if you want to call it UGC, user or agent generated content, AGC, who's going to consume that? Given the speed and the throughput of what agents can do, which is going to be hundreds and thousands of times.
On the same lines, I think about human trust, human relationships a lot, given this AI is growing up on an order of magnitude now.
Right.
And with agentic aspect, especially like OpenClaw, where agents are communicating on your behalf to other person, let's say, how do you think that it can manufacture your relationship? It can impact on that, that human segment of it that is very pretty natural to an individual. So what do you think, what could be future look like, let's say 5 years down the line, with something more beyond OpenClaw, given OpenClaw's, it is on top of the virtue right now.
Yeah.
So
again, a lot of even with so I think just to deconstruct, an agent itself, right? You have the workflow aspect of it. It's fairly deterministic. It's do a sequence of steps, and all of that. The non-determinism comes in when the LLM is actually involved, right? So that is, I think, where personality actually starts coming in. And for that, you have to go back to like ground zero research, right? Again, sorry to use the word ground zero. That's the name of your podcast as well. But what I mean is going down to the ground zero of research. So one of the evolving fields is about, even in LLMs, I think Anthropic recently spoke about this. It's called the persona system model.
Yeah.
So you can create softness in your character. You can create more aggressiveness in your character, just by doing training, right? Different steps in training. So I think eventually that will be the determinant of what your personality shows up when you delegate your credentials to an agent.
Yeah.
So it comes down to the ultimately the actual LLM itself and how it is actually specializing, what you have. And then there could be sequences of operations, depending on what your Telegram, communication is, what your Discord communication is, but all that can be reproduced fairly straightforward. But the magic is going to be in the sort of the LLM itself, which is where the probabilistic prediction token comes about.
I'm not sure if you have read this article or news or not. So what happened was there's this library called Matplotlib in deep learning settings, and what happened that the moderator of the repository was doing some commits also, taking some PRs, and someone's Claude, there's OpenClaw agent just came over on that repository and raised in the comments it just started bashing the moderator, like, I can just show you what your previous history has been, you are not trustable, you are not truthful. So given and the most surprising part was that the agent wrote a blog just on bashing on the guy, like on his activities, on his nature also. So, and this rose a lot of concerns, at least when people talk about model alignment and model restrictions with the human preferences, right? So I really think, this thing really needs some moderation. I'm not sure how long it might go up to. Anyways,
and if I was to add something on that one,
for sure.
I think that ultimately, your guardrails around like verifiable rewards, right? Based RL, reinforcement learning. So those are applied more towards mathematical, provable, exact things.
Yeah.
But RLHF on the human, I think that's how you're going to scale, the guardrails around that.
Yeah.
But yeah, to your point, I think ultimately it's going to evolve. Your context windows is going to probably confuse, the AI agent itself. Like in this case, maybe it went berserk because of some pollution in the context, window.
Or maybe the kind of permission the author has given.
Whatever, right?
It could be.
So it could be one of many of different things.
True that.
But unclear if the it fully represented the the wishes of the the person who delegated to OpenClaw. That is not clear.
True.
Right? So.
Totally makes sense. And one more thing, like we are living in the era of harnesses like Claude Code, Codex, Cursor. Right. I'm just curious, what are some of the side projects you are building with Claude Code these days?
Yeah. So, and you asked about interesting projects in general. One of the things we've done at Eigen is we built this thing called Mold Code.
Mold Code.
Yeah. So this is like basically.
So is there some agents writing code?
Court. So this is a court, like an actual high court, Supreme Court kind of thing.
If you know this thing called LLM Council,
right?
Which Karpati was just
hacking around. So think of it as similar. But the idea is that if agents have dispute with each other, can you verifiably adjudicate disputes? Using LLM as a judge, right? So so we did like a deployment of this on EigenCompute that people can go and verify. And the whole thing behind verifiability and bringing trust within AI and agentic systems is to have the kind of system that Eigen has built with EigenCompute. So yeah, I think that coming back to your question on what do I think of like Codex and Claude Code and all of these things. The technical innovation in some of these, again, composing different elements of computer science, is actually pretty fascinating. One of the, at least the way I, understood it, one of the big things that innovations within Claude Code was not so much like, the fact that it can generate code. That's been around for a bit. Like, so why did it happen like sometime late last year in December 25?
Yeah.
There were a composition of techniques. One is long-running agents doing long-running tasks, requiring minimal human in the loop.
Yeah.
The second thing is using something called abstract syntax tree. Right. Yeah. So ASTs, right? So this is what compilers also use to have like a construction of operands and leaf nodes and all of these things.
I remember my graduation thesis.
You remember the computer science of it.
Yeah.
And the combination of those two, and they call it neurosymbolic learning. And so the combination of those actually gave the accuracy, the strength, the autonomy with which the coding agent can run with for a long time, just given a simple prompt. That was the exciting thing, right? At the end of it. I'm sure, like, I haven't read about exactly how Codex works under the covers, but I'm fairly certain there's some version of it, where you're combining two different techniques and getting the best out of it. Even RL, for certain mathematical things, you can use formal methods and formal specifications in lean. And then that could become your reward function, it keeps getting better on like verifiable rewards and those kind of domains, right? It doesn't work in very subjective domains, but in math, it's possible. And so yeah, my to zoom out, I would say just excited that things are moving so fast, but it's also overwhelming. Like I can tell you, every single colleague of mine, person in tech that I've spoken to in the last 2 months, which is since Cloud Code has come about, feels overwhelmed with the amount of information that's there. How do they keep pace with things? How do they plan their roadmaps?
Exactly.
Nobody has an answer. And they find it like very hard to consume the amount of content that's there as well. So I think that's going to be for us as humans, it's going to be about prioritizing what matters the most and then running with it.
Also, I'm observing that most of these organizations, let's put example of, let's say, Eigen itself. So startups are actually absorbing what is happening on Frontier right now. So these Frontier labs are collaborating with some of the startups, some of the big techs, to actually let people in the organization start using instances of Cloud Code to work on their pipeline. So what do you think? Let's say, imagine hiring at Eigen. So what do you think next 5 months gonna be look like? Like, are you really gonna hire a junior dev? Because that's not gonna be one of the case. Because if you have a really good prompt engineer, I guess this is making sense now. Everyone needs a good prompt engineer. So what do you think, like, in terms of how software engineering is evolving, especially what these frontier model are trying to achieve? Like, at least what Anthropic is trying to achieve, making the model really, really good at coding, at software engineering and reasoning tasks, especially in maths and also. So what do you think, like, how the aspect of let's say the jobs of software engineering gonna have a trajectory, or at least in that sense?
Great question. I would say first off, I think, are we how are we going to hire, right? I think we will hire our token usage has gone up significantly since Cloud Code. And so I would say smaller teams move faster, and because there's less coordination overhead.
Exactly.
And so I think that's exciting. Now I would also say, like, I would say late last year, before Cloud Code came about, probably people were like getting more interaction with LLMs and getting the chatbot outputs and pasting them and all of these. It was less autonomous, right? In terms of code generation and things like that. Of course, with Cursor, you could with the ID you could move further. But the autonomy itself has changed. Like today, before you get into your car, before going to work, you can kick off a job and go to work and figure out some website design is off, or like, can you go fix the bugs? I've had this own experience myself. So that's one angle. So you're 100x productive potentially. But I will also say, from a hiring standpoint, probably the interview question I'm going to ask more is not how do you write code and prove that it works, the most efficient algorithm to traverse like a binary tree. That's one way to do it. I will also not say don't use AI or use AI. That's also not interesting. This was something like in 25, like people were like, hey, should you use AI? Is it okay for the interview candidate to use AI and stuff? And there's a confusion around like, is it good or bad? I think it's good to use it. I would say the way I would actually interview people is once an AI generated code is there, can they spot the security and functionality effects? How do they actually look at, did it do the right thing? It's not an easy problem because you have to consume lots of code, like, mentally, and also is it going to work? And so what's the QA step around it, and things like that. So I would say the method of interviewing is going to be more around, can you audit the code that the AI generated? I think that's going to be the determinant of things going to go to production very soon. Because it's one thing to put stuff in dev and like look at a website that looks nice, but would you trust it running your trading, like on your personal account?
True, very true.
So it's a big difference. High stakes use cases is actually where I would test.
Also, what I get a lot of query these days, how the market is gonna behave for, let's say, people who are junior devs, like, let's say, who have started working on projects, let's say 6 months, or and just want to work on a startup, or want to get into something. So how hard or how easy is for them to get aligned onto this stuff?
I think every time there's been I remember like when the internet came around, and I might be dating myself here, but I was alive when the internet wasn't here, right?
Oh,
and so it's
that's fascinating.
So
I mean, you have seen a
that's right,
a slight boom.
And so it was similarly disruptive, right? Same thing with the cloud and all that. And so I think it's when there is technology that is beckoning us and all that, I think the most important thing I would say is to see how you can embrace it, and then internalize it. Because sooner or later, something that's about productivity and all that, it's going to help humanity in general. So it's better to be part of the conversation than to be left behind. I'm sure even when electricity came around, people had questions of like, what is this thing? Is it going to shock us? Is it is it safe? How does this actually work? And but you know how like electricity, things like the railway themselves, the steam engine, all of these. There's some theory around this where it takes about many years for some generational technologies, category creating technologies like this that will actually take hold. So we're in that phase, I think, right now. People are still absorbing that. So it's no different from or probably it's higher on steroids on this one, which is, I remember a time when I was in college, right? I had to learn explicit memory management, malloc and free, if you remember these functions in C++. And so and then I remember when I went to Carnegie Mellon, I was like, there was a in that class people were like, oh, you don't need to learn memory management because there's Java and it does garbage collection. So a batch of students actually did learn how memory management actually works, right? How does fragmentation work? How do you defrag your heap and all of these things? I think there's a good fundamental concepts to learn. I would say it's the same thing with Gen AI. Just because Cloud Code and all these Gen AI tools are there, or Cursor and all that, I think it's still important to ultimately know how to steer a model. Right. Ultimately, the skill is going to be in steering. Your favorite tool to generate the right outputs. Right. Otherwise, you're going to struggle with validating and fixing bugs later on, right? And production issues. So so every stage has like you still need to go to some level of first principles and understand what some basic level of code means. You probably will not need to do the unglamorous things. But you still need to have an appreciation for that. So which means, steering is going to be a big part of like that. How do you steer a model to get the most optimal outputs?
You ask AI something, and it gives you a seemingly right answer, but from the wrong documents. Imagine if AI was a person in a massive library, and your vector database was a stupid librarian. The person asks for a book on photography or colors, and the librarian does return something with shades in it. But what if you had an ultra-intelligent librarian? You ask for the same thing, except this time, she already knows how to find it and where to get it. At HydraDB, we store the actual context, relationships that matter, decisions around it, how it has evolved over time, and everything that makes an agent intelligent. At HydraDB, we give context to AI.
So you have run infrastructure in places where failures are pretty expensive, especially in big tech and where everything is on stake, right? So what is the first thing you really think that people in AI underestimate when they say agents will handle payments, operations, or let's say negotiations in a marketplace? So what do you really think about it?
So the way I think about it at a high level is it's a state machine, right?
State machine.
Yeah.
How do you define state machine?
So think of it as like a graph with nodes and edges, and the edges are like some transition, from going from the system being in a certain state to the next state. That's like the first principles thinking here. Now,
I'm really liking how you are connecting everything with core system CS principle.
That's right, because ultimately, whether we like it or not, we're going to solve it. We're going to have to solve these things, right? And so when we talk about single agent, so that's one thing to look at. What does a security model look like in a single agent system? That itself has a bunch of states, and but it's all well contained, like within that graph or subgraph. And then you have different subgraphs interacting with each other when you have multiple agents interacting with each other. So when you say, when a payment transaction happens, does the payment actually happen after the proof of work, right? So actually, to draw a parallel from Bitcoin again, there's this thing called proof of work, with hash mining, that happens, and you prove that you mined it. And so it's a similar thing in agents, right? When autonomous agents are paying each other, these are all microtransactions. Like we're talking about like fractions of cents and whatever, right? So for the kind of work that's happening, what kind of dispute resolution is there to prove that when agent A pays agent B, that agent B actually did the work that it promised that it would do? So that's one kind of interaction model in state machine that you should think about. When do you roll back states? Are they a rollback? Are they immutable? So I think there's a lot of these kind of negotiation and non-deterministic things that can happen. I think it's still very early stages. people are just barely grappling with single agents like OpenClaw. But I think the multi-agent future, is where I think there's going to be more productivity and all of that. And I would also point to a very interesting thing in multi-agent frameworks. DeepMind about 10 days ago released a research paper on intelligent AI delegation. It's also it throws some light on what that constitutes. They also talk about how centralized providers like your hyperscalers and having agents only operate in their domain under their control is not going to work. There's going to be having you're going to have interconnects and interop on the internet. That includes reputation, that includes dispute resolution, and all of these are automated. So I think there's a lot more to come in exactly how this evolves, like this giga state machine, if you want to call it that. So.
Amazing. And I guess when I talk about security in AI systems, so Eigen is also playing a role in it. So what are the principles behind Eigen? I see you are building end-to-end stack on AI compute, Eigen infra, and a lot. So I'm just curious about what are your objectives here.
Yeah. So if I was to zoom out and say and maybe this is a useful isomorphism to have, which is if you look at the regular cloud, let's say in AWS, you have compute, EC2, you have persistence, which is S3, and you have Bedrock, which is inference and training and all these things. Think of that, all of that to be done in a verifiable way, in a trustworthy way. Right. So that's what Eigen is at a high level, right? So we have Eigen Compute, which is a little bit like EC2, but it's run in trusted execution environments.
What is trusted execution environment?
Yeah. So these are think of them as confidential computing, where you have hardware-based security, where the memory is encrypted, the key for that particular piece of hardware is etched into the hardware itself.
Okay.
And once a certain piece of code is running inside a trusted execution environment, a T, it cannot be tampered with. The execution cannot be tampered with.
Okay.
So think of it as it's compute encryption. Think of it that way. That's one way to think of it, right? You have data at rest, which is encryption and storage systems.
So why? Okay. So if I have to ask why we really need T, looking at the current systems these days, what about these models? So I really think that they don't have the T what you're talking about. So what that T brings here, which can actually, which actually matters the most, and which can actually, compensate the requirement.
Yeah. So it's really about privacy and confidentiality. Is really the probably the number one thing.
Okay. Privacy of what?
Privacy of the actual computation, the actual code that's running.
So what the prompt I'm writing to the model?
Yes, you could get that as well. Once that is, let's say you have a encryption from your client all the way into the T. Whatever the model is executing within, nobody can actually see what that is and where it is. So there's what we call at Eigen full stack, trust basically. So that involves all the way from compute to persistence, right, and inference.
Okay.
So all of this is the full stack. It's a completely tight link between all of these, and so there's no one place where you can lose confidentiality or trustlessness, of the entire system.
Okay.
Right. So you don't have to rely on any one counterparty like a hyperscaler on this, and that's actually the property of a blockchain. Is ultimately you can get permissionless and trustless execution as part of this. So T's are an important part of it. And what we do is, let's say you have a certain piece of code that we can then within our system we can prove that code compiles to a certain image, and that image is exactly what ran in your execution. That's the property that you get. It was not like that image was replaced with something, was tampered with, and then that execution is the outputs of those execution are attested on chain.
Can you help me with some of these stances where the problem you're talking about is actually happening in current world setup?
Yeah. So for example, trust is a bottleneck, right? That is our one of our hypotheses here, which is that for lots of coordination to happen, trust needs to be there between party A and party B.
Yeah.
I'll give you an example. Maybe the easiest way is to explain it through an example. We had a game developer who has nothing to do with blockchains.
Okay.
And one of the things he was saying is, hey, I'm running this tournament, which is a game, and ultimately I have a payout where people deposit money and there's a payout for the winner of a certain tournament. But people don't trust me in the payment algorithm that I have, right?
Okay.
So now just take that, as a problem we solved. And this person did not know anything about blockchains or anything like that. And then we just pitched the properties of our system that if you have your code open sourced running on the image running in our Eigen AI system or Eigen Compute system, then your code is verifiable. Your execution is verifiable. And the moment this person did that, the DAUs, like the daily active users and the MAUs, went up significantly.
Okay.
Because one of the hypotheses we have is the more trust you have, the more your TAM will be. More people will transact on your system.
Yeah.
That's the hypothesis we have. So that's the fundamental hypothesis that we have. Whether it's verifiable agents, verifiable code, but the more trust you have, the more people will start using it. That is the hypothesis.
And my next question would be, how are you going to verify it? What's the process of verification here?
Yeah, there's a few types, right?
Okay.
So on EigenCompute, we have basically, your T's themselves. Like you can prove the lineage of the code and the image that is running, and then that it executed correctly, and the results are persistent on the blockchain. The other way to do this, it's a little more expensive, is using, let's say in Eigen AI's use case, is to re-execute. So let's say that somebody asked you to run a particular job, and you said, I ran it and these are the outputs. Maybe it's Inference, maybe it's something else. If exactly the inputs that you were given, the code that you were given, is also available publicly. If somebody else can take the same set of inputs and outputs, inputs and the code that is being run, and then run it on their end, and then they say that, oh, Himanshu actually had an error in running this thing, and they prove it, then that's the other way of doing it. So that's called re-execution. You run it a second time, essentially. But you can only do that if the code is deterministic.
Okay.
Because if it's not deterministic, then you can't say if it's like your fault or not. So there's two ways to do this that we think about verifiability. One is the trusted execution environment, like where the code is compiled to a certain image, and that image is run cryptographically, securely. The other one is re-execute the outputs, and this is how Ethereum, how it works.
Yeah.
Right. So I think those are the two ways of doing.
Pretty interesting. I'm also curious about, let's say, 5-year ahead vision of yours. So you might be going to OpenAI and asking them to let this T, the trusted execution environment thing, being onboarded in OpenAI setup. Is this how it's gonna look like, or what?
That's a great question. So remember, for us to be able to use T's and prove verifiability, the source code has to be open source.
Oh.
Okay. And so then you compile that into an image.
Okay, let's say we are going to Chinese models and they're
open source. Then yes. So that's in fact our inference that we do is using GPT-OSS.
Oh,
basically.
okay.
So that's why it's open source, and that's whether it's DeepSeek, Quen, whatever, all these things. Those all Kimikator, all of these things can.
Okay.
But if it's like a company that has closed weights essentially, then of course a private weight. Then I think that's where the counterparty risk comes in, right?
Yeah.
So do you trust? So I think there was some news, late last year, where some frontier model company said that they've taken care of making sure their models answer mental health issues correctly.
Yeah.
They claimed it, but a few days after that, unfortunately, there was a couple of people who used those models, and they passed away because of suicide. So it's really unfortunate, but so I think. So that's the difference, right? Between verifiability of models and if a single counterparty like a large frontier company is running a certain model and they make claims, how do you know if it's true or not?
Yeah.
Right. And so I think this is where we come in and say, for open source models, you can actually verify the actual execution.
Pretty interesting, and I would really love to use it. So a lot of AI discourse these days is still benchmark centric, right? So, in your point of view, how do you think about what could be the better question for how smart a model is? Let's say GPT 6.1 came out, right? So, what's your go-to hypothesis, go-to eval to test how good the model is in terms of certain benchmark? Not public benchmark, but in your own eval, in your own, let's say if I talk about it in your own taste.
Yeah. So for subjective stuff, it's of course for taste. When you talk about taste, Let me talk a little bit about that. So a lot of like execution happens, right? There's this whole concept of the product guy, the idea guy,
Yeah.
And then the execution guy.
Execution guy.
You've probably heard about this. And so I think the execution guy problem is a little easier nowadays with all of this automation, right? With agentic code writing and all that. I think the onus is going to shift on the idea guy. How do you generate the right ideas? So your engineer is going to be like a product manager. Your engineer is going to be like a GTM engineer. So the onus shifts on the engineer actually, to do all those things. And so, so taste is a bit harder in that sense for eval, if you will. You may have outcomes like what's your usage, what's your ultimate DAUs and things like that. So that may be objective benchmarks to look at. But if you look at objective things, your SWE benchmarks and all of these things, that's a little easier to deal with. But even there's like I think I would say it's this continuous raising the bar. So let's say if a certain model is reaching like, I achieved like 62%, and the next time it comes 82%. Okay, now change your 100%, make that the new 100%, make it like 10x harder. So this is where you start getting into like, let's say general intelligence, and you can start pushing the frontiers. I think ultimately the more and more you keep doing this, you're going to get closer to like general intelligence, right? And so so benchmarking itself is like a huge. I know like there's PhD programs where people are working. I was at NeurIPS this last in 2025, and then I definitely saw that there's a lot more papers on benchmarking actually from PhD students, and that itself is like,
it is a different stream. It's a specific stream now.
That's right. It's its own discipline and research path, if you will. And so ultimately it's like, as I said, like that's the exciting thing about like everything we have with AI, not just the coding applications, but things like scientific research, things like drug development. That is something I'm very, very excited about. Can you have personalized medicine to improve health outcomes, for humans, right? I'm just super excited about that.
So a lot of these benchmarks are benchmarks, right? So, I mean, is there any formal way to verify task completion?
So it depends, right? Like if you look at, objective things, as I was saying in, with verifiable rewards with reinforcement learning, instead of like having the probabilistic model actually deal with a calculator problem, you can outsource that, to your tool and verify that. So this is what I was talking about using lean and theorem proving. This is with the math Olympiad. If you look at what happened with the math Olympiad, when people talk about the GPT was able to solve like whatever 80% of the Olympiad problems. Really, what's happening is at the end of the day, you're taking this RL and then making sure the model iterates until the right formal theorem is actually proven, essentially. So that's the reward, right? Every time you keep evaluating the model, like in RL. With the verifiable reward is that actually objectively achieving the task. So I think that is an area where it's a lot more tractable. Subjective is, I think it's a tougher one because there's taste involved. And so another example is prediction markets. You might have heard about prediction markets like Kalshi and market and all that. So that's where I would say there's ultimately somebody needs to adjudicate what happened with a certain outcome when resolving a market. And we've thought of like, for example, using judges, right? LLM judges. So maybe I think at that scale, you're not going to have a human in every single loop judging every single thing. So it's going to be some variant of a pre-committed model that's going to evaluate disputes or outcomes and subjective things as well. Maybe. So
I actually think a lot of this, the scenario coming from non-determinism of models, right? So this is the most interesting area of the podcast I'm most curious about, between determinism and non-determinism. So I mean, if I have to define what deterministic inference is, it is like if you're in the same model on the same input under the same settings, so you should get the exact same output, right? But we have non-deterministic inference from these frontier models, right? From all of these, what we say, large language models. And these non-determinisms coming from when we are tokenizing prompt, when we are and internally it is running many flops, many matrix multiplications, the operations, normalization, the whole attention mechanism is designed on that architecture, right? And then we are decoding next token and we are repeating the same, the same hierarchy of the thing. So if the model is mathematically fixed, my question is, why should output change? And I guess you guys have worked on this deterministic inference thing. So if you have to show some light on at least on this, so what do you think about it?
Yeah. So again, like I think that just to step back, I think again from a first principles, systems thinking standpoint, the abstraction that the LLM or Gen AI models have is that they provide based on previously seen probabilities.
Yeah.
Right. They provide next token prediction.
Yeah.
Now that doesn't necessarily mean for a given prompt, which is run many times when the model weights are fixed, that it necessarily has to provide different outputs. So it's almost like an artifact of optimization of keeping the inference hardware fully utilized. Right?
Yeah.
So you have batches that have, multiple GPUs can execute at the same time. So it's more like a hardware optimization problem that leads to non-determinism. So that's one way to look at it. Right? Another one is even in MatMul itself, like the kind of optimizations that are done. If you can serialize these, it's going to be a performance cost. So for all the techniques that are used to get determinism, if you can serialize the operations, or even have the floating, when floating point numbers are added, basically or operated on. It depends on the order of which you.
And even floating point is more likely like it is different in terms of how we study in mathematics and how it actually happens in GPU programming settings. Because it is associative, right?
Right.
A plus code B plus C,
right,
the same as code A plus B plus C.
Right.
At least in mathematics.
In mathematics.
But it is not same as
that's right
in GPU. So can you have an example like how it actually happens?
Yeah. So basically, there are, at the end of the day, there's lookup tables, right? For floating point, numbers, and then rounding is where it comes about.
Yeah.
So when your A plus B in braces plus C is different. It could be different from A, and in braces B plus C, right? And that's because you could have a different rounding in the first situation. So the compounding of this can completely lead to different probabilities, and outputs in your, as you compute your KV cache, for example, and as you try to get attention and things like that. So I think it's really small bitwise, execution that's off can yield dramatically different, results in the outcomes themselves. So that's one source of non-determinism. Then we talked about batch, invariance, right? So
I guess this is something what thinking machines
did that, right? So you have these tiles. They have like basically something called tiles. And if you chunk those into different pieces, and if they are variant, then you're going to have more non-determinism. Another one that another technique is the KV cache itself, right? So for example, if you have, let's say you have a certain a KV cache paged, and then for the attention mechanism to kick in, you pull it back into memory. The order in which the batches ran will be manifested in the KV cache and how it's loaded. So if you can make that deterministic,
isn't this something which will cause a lot of overhead as well?
It does. So thinking machines performance overhead was about 30 to 50%.
And how is it is for Eigen?
We have our technique is slightly different.
I guess it's more software aligned.
More software, and so we have like the Kublas kernel. We fixed the subkernels and all of that. So I think our performance impact is about 20%, and we have a paper we have written it, like at least empirically this is what we observe. So again, the point being, at the end of the day, these are all different techniques. There's no one right or wrong, but ultimately, going back to the property of auditability of inference, you need to have determinism to re-execute. For high stakes use cases like medical or legal or finance, you need to be having the ability to replay the execution and arrive at the same outputs. It's also the same thing with the way thinking machines use a lot of this is when if you don't have during RL, if you don't have determinism, then you're going to keep diverging. Your rewards are going to look different each time. And so obviously there's I think they are motivated by making sure that RL converges. And so the motivations are different. Like us, our motivation is to improve trust and auditability and verifiability. And their motivation is largely to improve RL and convergence and performance thereof. So I think they're just like different techniques and different goals, but ultimately trying to get determinism on these models.
Okay, if I go a bit diagonally opposite,
Yeah.
Why determinism in the first place? Because people appreciate creativity. People appreciate non-determinism of model. Let's say, let's say, see, I was really fascinated with this model called GPT-4o. It was really good at creative writing, and I really liked how for the same prompt it was coming with, let's say, 10 versions of it, and I really like, let's say, 6 of it. So I mean, I am falling for non-determinism here, right? And in a lot of cases people appreciate it. So why? So I mean, if you can point out to some of the use cases where determinism help, and why not to go for non-determinism? Because so many efforts being made, at least from thinking machines, the frontier of thinking machines working, you guys are working, even Grok has the like LPU design, at least on those front. So yeah, I mean, why determinism in the first place?
Yeah. So let me also talk about non-determinism itself, right? I think there's definitely like lots of use cases for which that's used. Our nature itself is non-deterministic. So if you go back to, again, taking first principles, if you go to quantum mechanics, right, or Heisenberg's principle, right, the wave nature of subatomic particles, that is already non-deterministic. We actually, for what it's worth, that electrons can, this wall over here, it could easily go through it. An electron can go through. You and me cannot go through it because you need lots of these things to align in the same way. Otherwise, we could be doing, going across the walls. Right? So that's like the first principles from a physics standpoint. Now, nature itself, like because of the physics, essentially, is already non-deterministic. Right? But in use cases where we want to reproduce things, that's actually where the number one thing, advantage of determinism. Another example is, forget AI and all that. Let's say you're writing regular code and you're testing it. You find a bug. Or let's say it's reported in production. There's a log that's in the system. And for the developer to be able to reproduce it, you need to be able to have that same execution trace to happen to debug the problem. I mean, without that, how, like, if it doesn't reproduce, then is the bug gone? Like, so I think, so determinism is important even in just regular software engineering itself, right? That's what I would say. Like, you don't actually need determinism other than to rerun something and prove something or diagnose something.
I mean, my objection could be here that even like given any prompt, or you have still that chain of thought or reasoning token there. Right. I mean, and I mean, you can share the code or not. I mean, you can even share your code with them or your chat with the model. It's up to anyone. So I mean, you can't really share the thing with the people that, I mean, what you have worked on, what the model is been really thinking. So I'm just trying to differentiate here how determinism can help someone in a way that where non-determinism is failing. I mean, I really think it could be in directions of transaction also. But if there are more, I'm just curious about if I have to really adopt determinism, let's say in 2 months, where I'm really falling off of non-determinism. So what those arenas could be?
Yeah, one is like high stakes, any high stakes domain, right? Maybe it's let's say that in medical use cases, a certain drug was given based on some inference or whatever. So you would want some level of auditability, for that, right? So that's one example. Another one is in trading itself, like high stakes, trading. Let's say you have an agentic trading bot. In order to know the history of that, why it executed certain trades, like you don't want that to be like magic or something, right? Like, so you want to know why it did what it did.
Do you think non-determinism is one of the main reasons why these language models are not adaptable to HFTs and trading and also?
That's one reason. Like the other reason is also like the latency, right?
Latency.
So when you have a centralized, order book, there's not much non-determinism, to be had over there. It's just a bid and ask matching, and all you're looking is trying to reduce the jitter in these HFT systems. So it doesn't apply directly, but let's say that an AI agent picks up, let's say, social signal, and then uses that to execute a trade. I think there it will make a lot of that. That could be an area where you could use that. So right now it's like the performance of AI systems is not like what we would be sufficient for like vanilla HFT trading. So those systems are operating in nano and microsecond latencies. So that's it's very straightforward problem of order matching. So the order book itself.
What I'm really getting from this conversation is you are treating determinism as an infra problem, and you are treating inference like a pure function of, let's say, model, architecture, prompt, seed, decode policy, and all. So if I bring the context of what you did on the paper side, so if you have to mention what did you have to pin control across the stack to make determinism practical on GPUs, and what surprised you most? I read like you have worked across let's say pair of GPUs A100 or H100, and there were some differences, but it really worked across homogeneous GPUs. So you enforce the same GPU architecture, and likewise on that front. So I'm just curious about what were the experimental results, because let's say on a large scale, given the adaptability, if people want to go for determinism with the same GPU or different GPU architectures, so what could they hypothesize?
Yeah, so I think it's a good question. I think our work focused largely on GPT OSS, and not at scale, right? This is like to make sure that we could actually do determinism in single GPU and all of that. But you can imagine future work where you'll have to serialize, and coordinate a little bit more like the thinking machines approach, right? Where you're looking at a little more abstracted set of streamlining that you have to do, and that's probably why you're suffering more of the performance overhead in their use case. So I think at a high level I would say the motivations will still be the same, but you're going to pay different performance penalty towards that. So it's just like at what scale do you want to run this? I think future work will in our case as well, once we see more and more interest and adoption, we'll probably look at like larger scale based on our own approach.
Makes sense. I've got this question from the community itself. What verification of inference can be sold to LLM providers? So there are many LLM providers. Let's open out itself.
Right.
So, and why would they buy that?
Yeah. So again, it's about the same thesis for verifiability and TAM. Right?
Yeah.
So the more verifiability you have, the more trust you have, and hence the more number of customers will start using that system. That's just the first principles of it.
Okay.
So if there's a use case that verifiability need not be applied in the places that it's not required, but if there's a use case where trust is a bottleneck for OpenRoute or whatever the use case may be, then I think determinism and all of that will be quite important.
You know what? I was actually drafting what questions to ask you, and since you have been working on deterministic and non-deterministic inference, so again going to the very first principles of it. If you can't differentiate the distinction between randomness and non-determinism, what could it be?
Yeah, so specifically the pseudo-random, the actual random number that you set, the seed, for your models and all that.
Usually we use 42 to get started with,
right? Yeah, but that for me that's still like it sets the amount of variance and the weights and the way the predictions happen in the tokens themselves. That's what it sets, right? And so, but if you're using pseudo-random number generators for something deeper than that, because that's still like a static thing for me. You could have, so long as the seeds are the same between two runs, I think you can still, and all the other techniques that we've talked about, you can still achieve determinism. Any external source that comes in and perturbs the system is probably going to end up with the wrong answer again. As in like not reproducible answer. Yeah. So I think that's how I would see that.
And how would you differentiate something if it is verifiable and correct?
Yeah. So verifiable is again if you have run A with a certain set of parameters, and then you have the same set of parameters and run B. If the outputs match, bitwise, logits, all of these things, then that's a match, and that is deterministic.
That is verifiable.
Verifiable.
Okay.
In that sense, right? Because what are you verifying there? You're verifying that the first run with the certain set of configs and inputs has the same outputs with the same set.
Okay, for audience, if I have to talk about a verifiable problem, let's say Anthropic posted this kernel challenge where you have to match the results or the baseline which let's say Claude 4.6 has worked on, and you have to match or let's say go over that baseline. So I mean, yeah, this is something you can verify even if given you can, I mean, mathematical problems, let's say lean, you can also, let's say the lean could be a verifiable problem. So I mean, yeah, so this is something which you can verify, and given also like if you can verify, let's say on I mean, if you have some examples which is verifiable on, let's say, high stake chance, so what could it be?
Yeah. So take that example itself, right? One of the things you could do is, and within blockchains we have this thing called optimistic, execution.
Okay.
So what it means is that, let's say you said your software would do something, like there's some properties and you're going to execute something and do that. Now you could have what's called an optimistic challenge. What that means is like, if nobody challenges you, then you're proven correct within the time window.
Yeah.
But if somebody challenges you, right, with that, so they re-executed whatever you did, like whatever this competition was, and they, with the same set of configs that you had for the kernel, whatever configs that you did, they prove that your execution was wrong, essentially. And at that point, you could have an economic penalty assessed, towards your claim, essentially. So that's where the verifiability, can come in, even in this scenario. So it's basically, and in agentic world also, this is going to happen. Where when an agent says that they have done a certain kind of work, or it has done a certain kind of work, it will eventually will have to have some sort of economic, property and bond associated with it. And other agents can, if they suspect this agent, they can re-execute what they've done, prove that it's wrong mathematically, and then get the proceeds of the economics, shifted over. So it's basically like a lot of this is about creating the right incentives to prevent, errors from happening. But whether it's malicious or not, right, irrespective. So you have to have these economic incentives for agents and hold them accountable, essentially. So it's not just for the Anthropic use case, like the contest that they had, but it could be applied in truly autonomous systems as well. This is how we're going to scale. It's not going to be possible for a human being to check every single thing. Right. So I think you have to have like autonomous, accountability mechanisms.
Or something like a co-scientist.
Exactly. Like, LLM judge, whatever. Right? So all of these. That's more subjective. But in some scenarios like this, where you're saying you wanted to achieve 79%, whatever benchmark that was, that's a little easier to assess because it's objective. The subjective ones are like courts and adjudication are a little more tricky. There I would see there's an element of governance as well, where there's probably like a stake-weighted committee that could randomly chosen so that you're not having collusion, that can come and ultimately resolve a dispute, right? Ultimately escalate to a human counsel.
Interesting. There's one more question I got from community itself. It was a large scale RL rollouts require very high task simulation, especially for coding benchmarks. So these tasks are verifiable rewards with RLVR. So any synergies in that domain?
I would say the thinking machines work definitely has synergies there. How do you converge? Right. Every time you're doing an RL run, how do you make sure that the system is actually achieving the outcomes that it's being trained on? That is, I would say, the number one synergy over there. And I'm just talking about not less verifiability, more about determinism. So the more you have determinism, more and more the RL will converge, faster.
To that, the next aspect I would like to diverge convert the pod is more on agents, RL and continual learning. So let's talk RL and agent training loops. Where does you think deterministic inference help most? So if I am debugging or reward hacking, or if I am replaying trajectories, or if I am evaluating policy changes on RL.
Yeah, a lot of these actually. To be honest, like any place where you need faster convergence or repeat the execution and get the same output. I think it could apply in all of those use cases that you talked about. Specifically in like I would say in let's say if the stakes are high again, like in context, long context windows and things like that. and there are a lot of techniques nowadays, right? Even in like if there's large context windows, how do you compact it?
Yeah.
And so, what if a certain run of the compaction yielded a certain set of like embeddings and vectors, and the next time you're trying to test it, it's diverging again.
Yeah.
So you have non-determinism. So you're not able to debug that. What compaction yielded. So that you can go to even larger context windows, right? Because that's how you can scale context windows. And so I could see a use case there as well. Yeah, where it's more on the building of it, and to reproduce, like to make sure that it's doing the right compaction. You would definitely use determinism there as well.
In agentic systems, the scary part is not often the model, but it's the tool called chain, which is just executing stuff. So how should people think about determinism here, where when the agent touches external APIs, databases, or let's say human inputs, and the possible outcomes can be, it could be anything. So what do you think about it?
I think this is such a nascent area. I think we are yet to scratch a lot of the surface here. I think first off we need to think about cybersecurity itself and the authentication and authorization models. Today you have like OAuth, OIDC, and then you have let's say SAML and IAM kind of systems. You have roles-based access control and those kind of systems. But I'd actually think that you're going to need more task-specific access control. So what I mean by that is, let's say you have an agent that is working within your environment, and it's inheriting the permissions of the user, but it's hard to the LLM is going to choose which tool to call, right? And then an MCP server and so forth. So it's hard to predict also which tools it's going to call. So just the dynamic nature of it, like because we're moving from an area of like static code analysis, which cybersecurity can deal with. You can set permissions and have it behave in the right way. To like something which is you don't even know ahead of time which tool it's going to call. And so I would say one of the ways to look at it is like there's this new area called task-based permissions. So let's say you are let's say trying to book some travel, right? And would you want your agent that you delegate to just have travel level permissions, like the task for travel? Should it have the ability to cancel it, like a sub-agent that you delegated to a long-running agent in case something happens with the airline, like you're seeing nowadays, like geopolitical events? So should it have the ability to cancel a ticket? So these are all like, I call it, think of it as a Venn diagram. You have high stakes permissions, like the most broad permissions, and then you have smaller and smaller. So like attenuating scope, essentially. So these are things that are not yet there in the industry, I think. So, but the point is, I think it's going to evolve.
Any synergies with self-improving agents? Let's say RL?
Yeah, I mean, like if you look at like at a high level where Bayesian, learning kind of things where models are dynamically updating the weights, and all that based on the context window, based on the human in the loop labels that come up with occasionally. Certainly, self-improving. I think that's also going to be an area that's there's going to be a lot more research and development in this coming year. But yeah, I think maybe applying some diffusion techniques, into LLMs, updating weights dynamically, and I think there's a lot I think that can be done there. But again, I come back to determinism because if you can't reason, like after some time that this agent has learned something over the last 30 days, even through the logs, and you can't reproduce it, I don't know how you're going to improve that system, right? It can't just be like just complete randomness and expecting good things to happen. So this is where I go back to even I think some of these labs call it mechanistic interpretability. So you have to have some intuition around these things, otherwise like you're not going to recognize the thing that you're getting on the other side like very soon.
Okay, so I mean, if I'm let's get into mechanistic interpretability. So what do you think of this horizon? Like, I mean, and so much work being done at least on this arena. Like, Anthropic has this paper, if you know, biology of an LLM, and I mean there are so many interesting people working on to really know what is happening within those neural nets, right? So if at least we can expect something out of it, so what do you think we should really go forward to? What niche we should let interpretability go forward to get into. So that could be, that can serve really, a good advancement in this field.
Yeah. So if you look at, I'll talk about like something specific and then go generic, like this LoRa technique, right? So where you actually like try to, inspect a little deeper on, exactly what's going on. So that's one tactical, piece. But then more interestingly, again, the first principles of this I think about is every machine learning technique has like an inductive bias.
Yeah.
Right. So it's basically, what is that architecture? It's making an assumption. Every single, ML problem or ML technique or an AI technique has, some sort of an architectural assumption that it's making that improves, outcome towards, some outputs that we're looking at.
Yeah.
So in decision trees, it's maybe like shorter trees are better. They generalize better than deeper trees, right? For regular decision trees. In neural nets, it could be like, the gradient descent itself, like reducing the entropy of the overall system based on the outputs that you're trying to get to.
Yeah.
It could be the smoothness,
Yeah.
things. So at the end of the day, I would say these are the things that, even in the long term, for continuous learning and all of these things, is that we have to have an intuition on this, and then see how close we can mimic the biological processes itself.
Yeah.
Right. There's actually some really good work happening in MIT and Dartmouth. There's a couple of professors working on this, and they call it biological generative biology. Is what they call it.
Interesting.
Yeah. And so in very early days, right, in these days of VLSI, and again going back to like first principles here, there was a professor at Carver Mead at Caltech. His name is Carver Mead. One of the things he said was, they were trying to emulate the human ear, in silicon. So can you emulate? This is like in the late 70s, I think. In fact, Carver Mead worked with, I believe it was either Hinton, the Jeffrey Hinton about the deep learning, awards and all that, to actually come up with some of those foundational questions, right? A lot of this is rooted in physics as well, like the Boltzmann. That's why they got the Nobel Prize in physics.
Yeah.
Because of the Boltzmann equations and Boltzmann mechanics. Ultimately, you're trying to reduce the overall energy state and looking at the hidden layers in the neural network. And so it's actually pretty fascinating in terms of where continuous learning can go. And I think that's why things like truly trying to understand why the model is doing what it's doing and how to steer it in different ways. I think it's going to be like paramount before we get into this next stage of maybe different model architectures and stuff like that.
Exactly. And like people have many such origins to it. Like, if I have to say in a way that, like one thing people like they might overestimate, and let's say if one thing they underestimate about, let's say, agent infra right now. So what could it be?
I think people are underestimating the trust and cybersecurity aspects of agentic infrastructure. It's very nascent still. Your Web 2 cybersecurity, some of it will obviously work along with observability and all of that. It's not going to be enough because of the dynamic and non-deterministic nature of the new kind of code that we're going to deal with, right? Which is very different from static analysis. So that's one thing I think is being underestimated. I think from an overestimation standpoint, I think that's an interesting one. I actually feel that the timing of it. I think again, it's no different from the model providers themselves, the frontier model providers. If you look at the overall business return on these things, it's taking a while, right? So if you were to look at like public market multiples and things like that, there's revenue multiples, but you can clearly see that the spend in AI and agentic is outstripping the returns. So I think that is an area that people are overestimating. They're expecting financial returns way more than what's actually possible in the near term. It's going to change, though. I think I'm very
There's a
optimistic.
meme, right, where people just prompt Claude, "Hey Claude, make me a startup," and yeah,
That's
you're a billionaire.
That's right.
Yeah.
Obviously, if with AGI and if everything was already there, then it would happen, but it doesn't. So, and that's the reason why. Because,
what do you think about AGI?
Well, I would say so. There's different definitions, but I don't think people even agree on like what's AGI and what's super intelligence, ASI. And so the way I think about it is, it's more like we were talking about benchmarks earlier.
Yeah.
In objective, yes, that's much more tractable. Like if you can do Math Olympiad kind of problem solving with LLMs, that's amazing already. But the subjective ones, I think that's where it's going to get tricky. Take an example of like protein synthesis for drug development and understanding molecules and how that can work. My own like assessment is that again, I'm sure like people can disagree with this because the definitions of AGI, not everyone is. And like the people have talked about like a country of geniuses in a data center, right? For me, if that like I'm looking more at what that country can accomplish.
Yeah.
Like, can it cure, let's say, dementia, right? Can it cure cancer? For me, that's already like general intelligence. It doesn't have to be like Skynet in Terminator, trying to like survive, right? And fight the humans. That's good sci-fi. But I would say I'm looking at more like important things to solve, for society. For me, that would already be general intelligence. Super intelligence is its own thing. Yes, there's this science fiction of it and all that. And then we can talk about different level of civilization based on harnessing solar energy and data centers in space. I don't think that's too far off. But at the same time, I think I'm looking at what outcomes we can have for society. That's for me like the more important.
And also there is one more paradigm called continual learning, or you can say lifelong learning, where models learn sequentially from a continuous stream of data, acquiring new knowledge without with retaining previously learned knowledge. So I mean, this is something like every researcher, every guy who is working on frontier is working on. I mean, they're of course this is a subjective thing for many of them, but at least like people say, like continual learning will be an integral addition to the progress of AGI and whatever we call that. So yeah, I mean, what's your viewpoint at least on that front, and how you think currently these models are capable of?
I think they will have to be model architectures that help with things like continuous learning, where it's learning. And today that's not like clearly the case, right? So I think that we are in a in that sense where I would say, and again I say early, but early doesn't tell you. I'm not telling you about the time scale, right? We're early, but this may happen in the next 5 years, right? AGI, and so with continuous learning, whatever, like just the how quickly Claude Code moved into like having this long running agent, using abstract syntax trees and actually delivering great code. If that kind of leaps can be had every quarter, which I think there's a scenario where this can happen, then we're looking at like compounding effects of this kind of innovation. AGI is probably less than 5 years ago.
5 years,
and so that would be pretty exciting, actually. So I really think that that would be exciting. Now, again, there's another school of thought, right, which is compute scaling the only way to like it's the only way out, right?
That's time compute scale.
And so only we'll have to see, right? Is there's a completely new paradigm?
Do you really think we need trillions of parameters of model for AGI, or something like a really good frontier? Let's say let's say like I'm talking about small language model, small scale reasoning model built in, let's say 5 billion or 2 billion parameter model. So something at least on that front.
I see. So again, if I go back to like my first principles on machine learning, like there's this problem of like overfitting, right? So you also want to make sure that you just don't do well on your training data, but also on your test data. Can it generalize well?
Yeah.
Right? And so, which is where I think some of these mixture of experts models and things like that, they actually, not just performance optimization, but they're also able to probably have more accuracy in their outcomes. So I think it's very much possible on the edge. The SLMs will, both for performance as well as other reasons, generalize better for the right tasks. I think there's going to be evolution in that, and maybe compute is not as heavily needed in the future as it is now. But I think that point is still some ways away. More importantly, I would say more interesting model architectures. We may not have even seen that today. Like attention was was a new thing, right? Less than 10 years ago.
Yeah.
And so that dramatically changed, how
the
learning
concept
is
of
done in general.
Yeah.
And so maybe there's something else that comes. What is that X? We have to wait and see. I'm sure some lab is cooking something soon.
Of course. I mean, so many things already being done. People are pushing open source efforts, especially if you can see the Chinese frontier. Labs like Kimi, Minimax, Zilum, even the DoDash equivalent of Chinese also cooking LLMs right now.
Right.
And they are actually the difference between the frontier, you can say the West frontier, the American frontier, which we call as the frontier model, frontier closest model, and the open source coming up. It's not. I guess it's not more than 2 months long. I mean, let's say if we have Claude 4.6 on XT, so let's say in X plus 5 days we have a really good model. Let's say GLM5, which is beating Claude 4.6 on long horizon tasks. So I mean, the frontier, the open source frontier is also getting close to the closed source one. So what do you think what's the durable mode actually where it will move? It is waits, post training, eval, or production. What?
Right now, and you're absolutely right that the compression of time between open source and frontier models, private weight models are it's happening. We see it, right? DeepSeek was the wake up call. There'll be more of that'll happen. One thing we haven't talked about is the energy itself.
Yeah.
Right. So the amount of energy it takes, the number of joules it takes, to get a token out. That's probably the most important metric here. Is whichever system has more access to energy in this particular model architecture of scaling compute is going to be the one that's going to help. And my guess is in China, energy availability has gone up a lot more than in the US, and that's how they're able to keep up.
Even Elon was also talking about how China is actually evolving on energy point of view, and they are creating various resources for that.
Correct.
They are not just dependent on one thing. Even I guess I have heard that they have created that artificial sun for the energy thing.
Yeah.
Yeah. So
there's
insane.
So energy, I think, is one thing we haven't talked about, but I think that's going to determine in this paradigm of scaling compute is going to be the thing that in the near term determines the compression between open source and closed source. And there's also again, this is just geopolitical. So I think it's just I'm stating something that I've heard about. I have no opinion about it. Is that the more open source that is there from, let's say, a certain country, they will end up dominating because most people are going to start using those open source models.
Yeah.
And so, let's say there's a performance difference of 20%, maybe they're okay with the use cases. But what the open source model countries achieve is that they get proliferation of their technology, and that's they get a hold of the supply chain in the long term. This is exactly what Meta did with Llama, right? That was first meaningful open sourcing of an LLM, and it deflated the value of every other lab. DeepSeek did that; it deflated it. Now Anthropic and OpenAI got ahead. So I think it's good overall for humanity when there's competition. I think, as I said again, if you can solve things like disease and all of that, those are important outcomes.
I guess we are pretty much to end of the pod, but I have, a couple of questions on that. So let's talk about people building in this era. I mean, they have got the resources, they have got models who can just code in less than 10 prompts. You can just ship a really good MVP, right? So if anyone is starting fresh today, what stack would you build around? Let's say maybe open weight or custom infra or frontier APIs or product speed. What you will optimize for? What you will go for?
That's a great question. I think there's tons of choices, and I think it's also confusing for people as to what to pick.
Yeah.
I will tell you what we do, and I do personally as well. Is we don't dictate a choice of stack. Within Eigen, we have people who use Cursor. We have people who use open source models. We have, of course, heavy users of like Cloud Code and CLI. I'm one of them. Codex. In fact, take the output of Codex and try to get it, code reviewed via, Cloud Code. So I think it's so early that I don't want to dictate, any one particular solution. And each thing is good for its own version. Like the only thing I'll say is like, the clear one is like, if you have a, token, financial constraint around, getting your tokens. And I think then of course you would go like, a little more open source and things like it. But from a fully integrated stack, it's a combination. I wouldn't pick one particular stack to work on. Things are evolving so fast. You cannot be stuck
Very
with
true.
one thing, right? And I remember even at Kraken I said this, where we were trying to sign a contract with one of these big, model providers, and I was very adamant that no long-term contracts. And this was 2 years ago.
That's insane.
And I don't think Kraken has even signed, a multi-year contract, because I think it would have not been good.
Do you think? I mean, the economy is gonna be just like that. What you're talking about, like no long-term commitments. And beat anything. Like you're just talking about a contract.
Right.
But it can have various dimensions to it, right? So do you think? I mean, this thing gonna prevail for a long time now?
It's a great question. I think I would say that there's a bit of concentration, like in the people who are able to accumulate hardware. Right. That's what's happening with this paradigm, this current architecture. And like look at Anthropic. Right. Recently there was some whether it was in South America or in the Middle East, some geopolitical events. Who could imagine that a model from a frontier company or a frontier model company would be the protagonist of achieving some military objectives. It's almost impossible to imagine this like 1 or 2 years ago. And there's of course a lot of like debates on both sides on is it the right thing to do and safe thing to do and all that. Those are the debates to be had, I think. But I would say that I think it's a bit hard to say if I think this will continue to evolve. I'm also very curious on domains like, as I talked about drug development for like solving human disease and aging and all those problems. Even in the medicine world, it could be used in ways that some people deem ethical and some unethical. So I'll give you an example, right? Let's say that, by the way, have you heard of this K-shaped economy? In the US, right?
It was recently, I guess it was popping on my timeline like anything.
There you go. So the rich are getting richer, the poor. It's happening, right? You can see it. And how does society react to this? One of the ways this could go bad in the using Gen AI for like the medical area is, what if only the people on the right side of the K get better treatment because they can afford those kinds of personalized medicine, and because of the LLMs and tokens that they have. Like I know I said a few things here, but just imagine that future, right? Like, is that even fair?
True that.
And so so I think a lot is going to change here.
I mean, a lot is being done and a lot to be done, and we are really not sure what's going to happen. But we can just be hopeful enough in a very sovereign way, in a very, I guess, which just leads to bettering the humanity as fast as we can do, as more as we can do.
Right.
So I guess this is pretty much the last question to you, at least for this podcast, is a lot of people right now are just kind of hacking around these days, experimenting with the stuff coming up. A lot of people are just in the generic, the what they have been told to do. They are just doing that. So according to you, what someone who is just 20-year-old starting out college and just seeing people working, so much things happening, there's a bubble, right? So I mean, so what should they optimize for? What should they look forward to? I mean, which can reward them. I mean, we are really not sure what's going to happen, but at least let's say which gonna be rewarding for them in a fragment of time, which is not really far, but yeah, because a week is like a day right now, like even smaller. So I mean yeah, at least on that point of view.
This is probably the toughest question of the podcast, but
I think so.
I have an opinion.
Yeah.
And the reason I say that is it's hard to predict, right?
Yeah.
But I think something that's been invariant in my own experience is just being very curious.
Curious.
That's the number one thing. Like, so long as you're very curious.
I don't know. The number of times I have posted this, everything is just about curiosity.
Right.
I mean, even the pivots itself
Right.
are like, let's say if someone want to go from text-based AI to vision to diffusion AI, anything.
Right.
It's just about curiosity. Once curiosity.
That's it, right? So if you're curious, I think you will find the path yourself.
Yeah.
And I think that you will be knowledgeable to, make the right decisions at the right time for your own self. I would say that's the I apply that principle myself. Like, as I said, I worked in like all the way from silicon to like operating systems to cloud to blockchains to AI and all of that. And I think I was just curious about why things work the way they do, and also look at outcomes. Right? So one other way to look at it is outcome-based, contributions in society. So that's going to be important. And so, will it make something better, faster, cheaper?
Yeah.
By orders of magnitude. Then just be curious about those things, and just read up on the latest. And this is the advice I use myself.
Yeah, that's honest and totally practical actually.
Yeah.
Totally pragmatic. This was such a sharp conversation. We just not talked about how AI is getting smarter, but what it takes to make systems trustworthy. And yet I really liked how you just the very first principle to the system perspective of it. So anyone, like if anyone studying in college, they can correlate to what it actually need to get the system evolving, even if you're learning the core CS principles, right? And I guess we covered everything from agent infra to long horizon tasks to open source models to what actually verifiability and trustability actually gonna do, and yeah, a lot of stuff. And yeah, Vishnu, thanks for giving out a good time with us. I really enjoyed it. I really enjoyed the conversation, how you got into the depth of it. Yeah.
Amazing. So Himanshu, again, thank you very much. I know that you do great work with the podcast as well as other things, and so it was really fun. Like how deep you went as well. I think I enjoyed these kind of technical things as well. So not just technical, but we covered different areas, society and impact and policy and all that. So super exciting, and thank you for having me here.
Appreciate for joining us. Stay tuned on Ground Zero. This was episode 10. See you next one. Bye.